All right, we are working on notes. It's page 50 in the packet. It is the Pythagorean Theorem, and it's Converse. I think Pythagorean Theorem is something we know. It's just something that sometimes we misuse. I assume you have your calculator ready to go. So, little comic here. You may be right, Pythagoras, but everybody's going to laugh if you can't call it a hypotenuse. If you call it a hypotenuse. Oh, yeah. Anyway. Let's just move on. All right, so the history of the Pythagorean theorem. I'm going to go over this quickly with you because I think it's important. Pythagoras is considered the father of numbers. He was an ancient Greek mathematician who lived around 500 BC. Pythagoras led his own society of men and women called the Pythagoreans. They lived very simple lives with long hair and bare feet. They had a strict, primarily vegetarian diet that did not eat foods thought to be impure, such as beans. Okay, remember, this is a long, long time ago. Pythagoras studied philosophy, astronomy, music, and mathematics. His main work was music and mathematics. In both fields, he put order to the chaos. According to Pythagoras, music is noise that makes sense, and mathematics is rules to know how the world works. Pretty wise beyond years here. Although the ancient Sumerians used measurement of the Pythagorean theorem as early as 2,000 years before Pythagoras' time, Pythagoras is credited with the theorem. This is because he proved the theorem to be true for all right triangles. So even though this whole triangle theorem existed, he was the one who actually proved it to be true, which is really hard to prove something true. So we call it the Pythagorean theorem, named after Pythagoras. It's not some random word. Okay, now, has to be a right triangle. That's the big thing. Okay, if it's not a right triangle, you cannot use Pythagorean theorem, and we have to use other ways of getting there. Now it says the sum of the squares of the legs of a right triangle. Okay, the sum of the squares. When I square something, I'm actually making a square out of it. So when I say squared, I'm saying take A times A. I'm building a square off this side of the triangle. And B, this is going to be a big square, times B. So the sum of the squares, so if I find the area of an A by A square and a B by B square, that would be equivalent to the area of a square that is C times C. So Pythagoras' theorem is really taking squares off of each side of the triangle, saying the square of this side plus the square of this side equals the square of that side. We don't actually draw squares and find the area. We just take A squared plus B squared equals C squared. Now, A and B are the legs. The legs are off the right triangle, and C is the hypotenuse. Hypota, and then N-U-S-E. All right, so label C the hypotenuse. But that's what people mix up. They just plug any numbers in. A and B have to be off the right angle. C is the hypotenuse. So we literally just square the number, but squaring the number is really finding the area of a square that has a side length A, and the area of a square that has side length B. If we add up these two squares, or we took this square, put it in here, and chopped this one up, it would fill up this square. So if you can picture taking this, putting it in here, and taking this and sort of filling in the missing pieces, we would have these two add up to big square. Okay, so let's get into this then. So it says find the missing side, round all numbers to the nearest hundredth. How many decimal places is that? Nearest hundredth. 2 places. Yep. Oh, so good to have you back. Someone talking to me. All right. Sometimes some of them talk to me. All right. Side C is always the hypotenuse. That's what we just talked about. So I don't want just an answer. We are going to show that a leg squared, 4 squared, plus 3 squared equals, I'm going to call the hypotenuse C squared. Now I'm fine with you typing this in the calculator. You have to have one. 4 squared plus 3 squared equals 25. Now, here's the deal. On the left, I have 25. On the right, I have C squared. How do you get C by itself? How do you get rid of a square? What's the opposite or the inverse? I know you know this. Square root. Look on your calculator. See your little x squared key? Right above that is your square root key. See, x squared inverse square root. This is any power, that's your any root. So we would come in and say, well, to get rid of the square, I would take the square root, If you do it to one side, you do it to the other. So what does C equal? What is the square root of 25? 5. And you guys know that. The square root is what times itself equals that number. What times itself equals 25. All right, so go ahead and set up 9 and 10. We'll go over those. So set up and do 9 and 10. All right, so the setup for this one will be the leg squared, 4 squared, plus the leg squared, 8 squared is x squared. I mean, that's 16 plus 64, and then you can add them up. You can type it all into your calculator at once. And I get 80. So 80 is equal to x squared. Now, we haven't really played with square roots, so we are only rounding them. We're not worried about the exact numbers. So I know that the square root of 81 is 9. So this is not going to be a nice number. This is not a, when I take the square root of it, it's not going to be a rational number. So square root of 80, and I get 8.944. It's the nearest hundredth, so 8.94. And if it does tell you what to round it to, you need to round it properly. All right. Now, if I take 8.94 and I square it, 8.94 squared, I'm going to get really close to 80, but not exactly 80 because I rounded it. So this is not an exact. This has been rounded. All right. Leg squared plus a leg squared. Again, that's 36 and 24, but I can throw it in my calculator. 6 squared plus 4 squared, and I get 52 equals x squared. I missed my square. And so every time I do one of these problems, I now need to take the square root to cancel that. Now, the square root of 49 is 7. So this is going to be a little bit above 7. I have to estimate it. So square root of 52, and that gives me 7.211. So I'm going to go ahead and keep the 7.21. Now, if we're being really technical, we could put this sort of wavy looking equal sign in these last two because these are approximate answers, not exact answers. All right, go ahead and look at number 11. Take a second and see how you would set that one up. All right, so the reason I asked you to try this one is I want to make sure that you saw 12 is a leg squared, y is the other leg squared, and that equals 16 squared. Did you set that up correctly? So this would be like your A, which is a leg, and your B. A lot of people will do 12 squared plus 16 squared. But guys, it's got to be a leg plus a leg equals a hypotenuse. Now, I've got a little bit of work to do here because I can't just add these up. So 12 squared is 144 plus y squared. And then I got to do 16 squared. And I think I know it. 256, yep, 256. Okay. So in order to get y solved for, I have a little extra work to do. I'm going to subtract the 144 to solve for y, just like we do with order of operations. I get y squared equals, double check my numbers, 112. And then that y squared, I need to get rid of the square. So I'm going to take the square root. That is its inverse. Now, again, you're going to have to get to know your perfect squares, but like 100 is 10 times 10. 121 is 11 times 11. Those are those numbers on the diagonal of your times table. If you remember doing that 1 through 12 times table when you're little. So I know my answers be between 10 and 11, but it's going to be a decimal. So I am rounding it. Square root of 112, and it is 10.583. So 10.58 is the nearest hundredth. I'm going to go ahead and put that approximately equal to. And there you go. So with that in mind, go ahead and look at 12 and 13. Make sure you pay attention to which ones are the legs and which ones are the hypotenuse. I'm going to pause this while you work. All right, so in number 12, you should have x squared plus 7 squared, or 7 squared plus x squared equals 10 squared. That's x squared plus 49 equals 100. And so I have it all separated. I'm going to go ahead and subtract the 49 from each side. I should get x squared equals 51. And then we're going to have to throw that in our calculator, and it should round. Let's see. It's going to be really close to 7. Square root of 51, 7.141. So we'll round it to x is approximately 7. What did I say? 14. I almost wrote it backwards. Okay, so square root of both sides is how we got there. Now look at number 12. I'll call this A. It doesn't matter as long as the legs are the A's and the B idea. So a squared plus 4 squared equals 12 squared. So that's a squared plus 16 equals 144. Subtract 16 from both sides. A squared we'd have to borrow, so I think it's 126 or 128. Did I do 144? Oh yeah. 120. Good thing I double checked myself. Okay, so it's going to be a little over 11 because the square root of 121 is 11. So I'm going to throw that in my calculator. Square root of 128, and you can see it's 11.313. So nothing's really been rounding up. So it's approximately 11.31, and that is my answer. All right, so let's talk about this next piece. It says, can use the Pythagorean theorem to solve for the missing side of the following triangle. Okay, so I'm looking at it, and it looks good. It looks like the last 3 problems we did. We have the 2 sides and the hypotenuse. There's an important thing that there's a reason I cannot do it. So, no. Why can I not? I'm telling you I can't. It looks good. Everything's there, almost. It's not a right angle. Doesn't matter if it looks like a right angle or it doesn't look like a right angle. It's all about its labeling. So, no, cannot use Pythagorean theorem. And you can abbreviate a theorem to THM. You can't use Pythagorean theorem because it is not a right triangle. Always has to be a right triangle. So if they would have told us it was a right triangle, if they would have marked it as a right triangle, even if it doesn't look like one, we can use it. But that was not marked as a right triangle. Okay, so next idea is the converse of the Pythagorean theorem. So go ahead to that next page. The converse Pythagorean theorem can help you determine whether 3 measures of a triangle make a right triangle. So if I know 3 sides, I can tell you whether they are or aren't a right triangle. So here it is again. The sum of the squares of the lengths of 2 sides. Okay, so that's that a squared. Actually, this is b, sorry. B squared plus a squared equals c squared. Now, how did I know what was supposed to be labeled what? And you do need to pay attention to this for later. And I shouldn't have had the little square there, sorry. What you want to pay attention to is the vertices are labeled capital A, B, and C, and the side opposite, remember we talked about opposite sides, is labeled lowercase a, lowercase b, and lowercase c. That's actually really important to us when we get into the next thing. So vertices are always capital letters, and the length of the side, so this touches these two. Angle A is formed by these 2 sides. This is side A. Side B is formed here. The opposite that's not touching it is side B. So remember that term opposite. Okay, if this is true, if a squared plus b squared equals c squared, then it is a right triangle. So if A, B, C make a squared plus b squared equals c squared true. If it makes it true, then the triangle that you were given, ABC, is a right triangle. Okay, so we're doing it pretty general here. So if the 3 sides, ABC, make the Pythagorean statement true, then ABC is a right triangle. Guys, here's what I need you to understand. The hypotenuse is always the longest longest side. Now, if you can picture, make this a right angle. If I had to go from B to A and I walked from B to C and C to A, like I had to go around the block, that is going to take me longer to walk these two short sides than to cut the diagonal. However, the diagonal will always be longer than the two legs. So picture me walking from point A to point B. This is the shortcut, cutting through all the yards on the block. But if I can't cut through the yards, it's going to take me a little longer. So the shortcut is shorter than these two sides together. But due to that, it is longer than both of these sides individually. So how do I know which one's A, B, and C? C is biggest length, always. C is the biggest length because it represents the hypotenuse. All right, so I'm going to label this A, label this B, and C. It's not always in order, so let's test it. Does 9 squared plus 12 squared equals 15 squared? And this is why I wanted you to have a calculator. I'm just going to simply type in 9 squared plus 12 squared. Those are numbers I can do in my head, and I get 225. Well, guess what 15 squared is? 225. So that's true. So this is a right triangle. So I'm saying yes, it is a right triangle because it holds the Pythagorean theorem true. Okay, I'm going to call A 10 or 10A. What should 26 be? B or C? It should be C, and then 24 is B. So fix the order. 10 squared plus 24 squared is 26 squared. All right, I'm just going to type this in my calculator. 10 squared plus 24 squared. That gives me 676. Okay, so all I have to do now is type in 26 squared. And it gives me 676. So another right triangle. All right, go ahead and you do the next one. Label the A, B, and C properly. Bless you. All right, so I'm going to let the 3.1 be the C squared. So it doesn't matter if A or B is bigger. It matters that C is the biggest. All right, so here I go. 2.5 squared plus 1.7 squared equals 3.1 squared. I'm 100% using a calculator on this one, but 2.5 is the same as taking 25 squared, and we just adjust the decimal. But I'm going to let the calculator do the dirty work, and that gives me 9.14 on the left, and then 3.1 squared, 9.61. Close, but not the same. So my final idea is this is not a right triangle. So you need to state each one, and you need to have proof. So you don't want to just have an answer on these. You need to show the proof. Is it true or not true? And then state whether it makes a right triangle or not. Okay, so last idea for today is the Pythagorean triple idea. Okay, a Pythagorean triple, actually that should be a capital P since it's the name of something. Pythagorean triple. I'll fix that. Pythagorean triple is three whole numbers that satisfy the equation a squared plus b squared equals c squared, where c is the greatest number. Okay, we already know that. One common Pythagorean triple is a 3, 4, 5. Here's the other big thing. You ready? For it to be a Pythagorean triple, they have to be whole numbers. And we probably just read over that. Whole numbers are like the number set 0, 1, 2, 3, ... There are no decimals, no fractions, no parts. They are literally whole numbers. And obviously we can't have a negative number because it would be not a length of something, okay? So if the measures of the three sides of any right triangle are whole numbers, the measures form a Pythagorean triple. So go back to the front real quick. Numbers 15 and 16 made a right triangle. Okay, they made a right triangle, but what's more is they are Pythagorean triples. And again, that should be a capital P. They're Pythagorean triples because all three sides were whole numbers. This is a right triangle, but it goes further. It is also a Pythagorean triple. Now, if it's not a right triangle, it can't be a Pythagorean triple. Okay, if it's not a right triangle, it cannot be a Pythagorean triple. But even if this did work, it would not be, it'd be a right triangle. Let's say if we adjusted the numbers, it would be a right triangle, but it's not a Pythagorean triple because of the decimal. So if it's not a right triangle, it cannot be a Pythagorean triple. Now, let's look at the back here. Is this a Pythagorean triple? You can't just say yes. It could be because they're all whole numbers, so it could be. These are all whole numbers, so it could be. Guys, I don't even have to try this one. Not a Pythagorean triple. Why don't I have to try it? Because that 4 squared to 3, the minute I have this is an irrational number because the square root of 3, there's nothing that gives me that as a whole number. So if I type in 4 square root 3, see how that goes on and I have to round it? It's not a whole number. So I don't even need to test this. Now, this could be a right triangle, but it's definitely not a Pythagorean triple. So do me a favor, test and see if these are right triangles. If they're right triangles, then they are Pythagorean triples. All right, so we still have to look for the three numbers and think, oh, A, B, and C, the longest side. So does A squared plus B squared equal C squared? So I'm going to let my calculator do the work. 8 squared plus 15 squared. I got 289. And I don't equal 256. So this is not a right triangle. So if it's not a right triangle, guess what? Definitely not a Pythagorean triple. I mean, a Pythagorean triple has to come from right triangles. So if you just jump in and say, oh, look, they're all whole numbers, no decimals here, that's not true. It has to be right triangle. So it's not a right triangle, so it's definitely not a Pythagorean triple. Okay, next one. We've got the two smaller sides. 41's the bigger. So 9 squared plus 40 squared equals 41 squared. That's what we're looking for. Okay, big numbers. We get 1,681, and 41 squared is that same value. So this is, I'm going to write, this is a right triangle. And more importantly, it is a Pythagorean triple. And that is because they are whole numbers. So you have two things to look for there. Now the last one we already stated was not a Pythagorean triple, but let's just see if it's a right triangle. Now to do this, I have to be very careful. 4 square root of 3 squared, like that, plus 4 squared equals 8 squared. Now, I estimated this to be about 6.93. That's what I rounded it to, so that's how I knew it was the smallest number, or this one of the smallest. Now, when I go to put this in the calculator, you have to be really careful. Pay attention to this. It's 4 square root, and then I have to type in the 3, and now in this calculator, I have to close the parentheses. Now, if I type in squared, what I need you to see is I get the number 12. That's 100% wrong. I need to put in parentheses 4 square root of 3, close the square root parentheses, and then close the big parentheses. Now, in the Smart View calculators, I think it puts your little root underneath it, so you don't need the parentheses. But in this, I need 2 sets of parentheses, and then I put the power of 2, and I get 48, a very different number than 12. So this is 48 plus 16. Does that equal 64? So this messy number ends up being a really nice number when I square it. Just want to show you, if I would take out this parenthesis, I get that 12 again. Your calculator is squaring this 3 first and then multiplying it by 4. So it's saying square root of 3 squared is 3 times 4 is 12. So you be really careful. All right, 48 and 64 is 48 and 16 is 64. So listen, it's not a Pythagorean triple because of that decimal, but it is a right triangle. So right triangles they fit the Pythagorean theorem. Pythagorean triples are a right triangle that has only whole numbers. That's the big difference there. It should be a very, very simple thing.